The objective of this lesson is to divide using open area models with two-digit dividends. In previous lessons, students learned to divide a total or dividend using area models. This model allows students to subtract out multiples of the divisor, or chunk out the division into groups of tens and ones using partial quotients. With multiplication, we know when we have both factors, we can find a product. With division, we have one factor and the total. We divide to find the missing factor. In this lesson, we will need to know and use the proper terms for the parts to a division problem. Students have learned quotient, divisor, and dividend. The quotient is the answer to a division problem, or tells how many parts will belong to each group. The divisor tells the number of groups our total will be split into. And the dividend is the total amount we will be splitting or sharing amongst the groups. Let's begin by solving the following problem. The Davis County Track Club has 96 participants and staff members. The club members will be going to the state meet in St. George, and they will ride together in vans that carry 8 passengers each. How many vans will they need to transport everyone to the meet? Let's divide by using the open array. Our total, or dividend, is on the right of our array, and the number of people that can be grouped to ride in one van is 8 as our divisor and a factor of 96. We are looking for our missing factor to describe the number of vans we will need for transport. With a two-digit dividend, a great strategy is to check for groups of 10 to divide or subtract out first. We need to decide if we can give each of the 8 groups a set of 10. Since 8 sets of 10 is 80 and 80 is less than 96, we know we can. Give each group a 10 and then subtract 80 from the total of 96, leaving us with 16. Some students will observe that they may simply use the completely open area model and use 10 as the other factor to solve for 8 sets of 10, which is 80, and that will be our first partial quotient. 96 minus 80 is 16. We have 16 left. We can no longer give each group a 10, so we draw a vertical line to finish off the partial products of 10, and we divide or share the 16 between the groups of 8 people. Notice each group can get 2 more, so on my open area model, I place 2 at the top of my next column, and I multiply 8 times 2, which equals 16. When we subtract 16 from the 16 left in my dividend, we now have 0 people left, so I have completed the division. Add the partial quotients, and notice that 10 plus 2 is 12. 12 is the missing factor, as 12 sets of 8 will equal 96. 12 vans will be needed to transport the track club and its staff. Let's try one more on the simplified open array. Luke had collected $65 to spend on pizzas for the soccer team party. If he paid $5 for each pizza, how many pizzas could he buy? Let's set up the open array. Put the total or dividend of 65 on the right, and the divisor of $5 each on the left of the array. We are working with a two-digit dividend, so first try to come up with sets of 10 to give each group. Notice that we can use 10 as a factor because 5 times 10 is 50, and 50 is less than 65. This model shows 10 as a partial quotient in the division. Next, subtract 50 from 65, and there is still $15 left. We cannot make any more groups of 10, so draw the vertical line and move on to the ones. Finally, we exchange the 10 for 10 ones, giving a total of 15. At this point, we know that we could give 3 to each group, or we could repeatedly fair share, giving 1 to each group and then 1 again 2 more times, making 3 as another partial quotient. We subtract 15 from the $15 left in the quotient, leaving 0 remaining. When we add together the partial quotients, we find that he can buy 10 pizzas and then 3 more for a total quotient of 13 pizzas. Using multiplication, we found 13 times 5 equals 65,
so 13 and 5 are both factors of our quotient 65.
As students begin to work division models with open arrays, they will make the connection between multiplication and division. The divisor and quotient work together as factors, and when they are multiplied together, it gives a product that is equal to the dividend in the division problem. The objective for this lesson was to divide two-digit dividends using open area models. Students met this objective by subtracting out multiples of the divisor and adding all these partial quotients together.